Okay, so dilations. Like I said, it's kind of the last one in the set. So we did translation, reflection, rotation, dilation. I'm going to sneeze. We've actually done something very similar to dilation already because it's very close to similar figures. And we did similar figures back a couple months ago. So this is very close to similar figures. When you have a dilation, they're going to give you a dilation factor. If this number is greater than 1, it is an enlargement. Which means it's going to be getting bigger. If that dilation factor is less than 1, it is a reduction. So if it's bigger than 1, it's getting bigger. If it's less than 1, it's getting small. So number 1, we have a dilation of 2, which means it's getting 2 times bigger. So whatever this number is, we're going to multiply by that number. So we have to figure out what the coordinates are. So we're going to find out the 3 coordinates, because this is a triangle, and then we're going to multiply it by 2. So x, your original x is at 0, 2, which means my new x, remember we can put a little 1 there to show that's the new one. It's the first time I changed it. Multiply both of them by 2. Well, 0 times 2 is just 0 again. I get 0, 4. So 0, 1, 2, 3, 4. That's my new x. Is up there. So y is currently at 2, negative 1. So my new y, multiply both of them by 2, 4, negative 2. 1, 2, 3, 4, down 2. There's my new y. That's the new one. And then the last one up here, w. So w was at negative 1, negative 1. So the new w is at negative 2, negative 2. Reconnect everything. That is my new triangle. So it's twice as big. It's twice as big. Now, sometimes on the state test, they'll say something about which one of these does not hold congruence. Dilation is the one that doesn't hold congruence, because if you translate something, reflect something, or rotate something, you're going to end up with the exact same shape again. Dilation, you're not going to end up with the same shape. It's either going to be bigger or smaller. It's similar. It's not congruent. It's a similar shape. And also notice I changed the dates up here because they changed the dates on us. So the geometry test got moved up by a week. So April 27th and 28th is now the new geometry test. So hopefully they don't change the date on us again. But it got moved up a week. So number 2, we're going to do the exact same thing. Find your coordinates. So F, 0, 2. The new F, this time I'm multiplying by 2.5. Well, 0 times anything is 0. 2 times 2.5 is 5. So my new F is up here. That's my new F. Then we're going to do the same thing for G. So G starts out as 2, 0. We're going to multiply by 2.5. So we get 5, 0. So it's going to be here. That's the new G. And then the last one is -1, -2. So E, -1, -2. Now this one's a little bit tricky to graph because -1 times 2.5 is -2.5. -2 times 2.5 is -5. So from here, you're going to go -2.5. So it's going to be in between the two lines and then down to -5. So that's the E. So some of these end up kind of in between the lines. Sometimes you end up with decimals or fractions. So there's my new figure. Yes?
How are you getting 5 from 2?
Say it again.
How are you getting 5 from times 2 or 2.5?
So if I have 2.5 times 2, it means I'm doubling it. 2 times 2, 4, 5.0. So I'm doubling the 2.5. Or technically, I'm taking 2 times 2.5.
Yeah, makes sense now.
Other questions? So those first two are enlargements. I went from the original shape. My dilation factor was bigger than 1, so it grew. It enlarged. Now my next two are reductions. You may need more time on these two? You good, Richard? All right, next one. Now the next one, I'm going to make my thing bigger. It's got a dilation factor of 0.25, so it's a little bit tricky to get it graphed in here just because it gets so small. So, same as we did before. We got to find our coordinates. So G starts out as 1, 3. Now, in this case, I think it's a little bit easier to think as the 0.25 is 1/4. So I need a fourth of those things. So my new G, a fourth of 1 is a fourth. A fourth of 3 is 3/4. Now, like I said, it's a little bit tricky to get graphed in here just because it gets so small, kind of compact in the middle. So it's going to be 1/4, so not even to the half, about 1/4 of the way. 3/4, so it's going to be right about there, is where the G is going to end up. So that's the new G. And I can mark that G. Let me put G here. G. Now H, 2, 1. My new H, now a fourth of 2 is a half. A fourth of 1 is a fourth again. So again, it's really close to the middle. Half, fourth. So it's like right here. Right about there. That's my new H. So like I said, this one gets really small. It's kind of hard to graph there in the middle. I starts out as 1, -2. Take a fourth of that. I get 1/4 and -1/2. So 1/4, -1/2. So it's going to be about here. So that's the I. I got one more to go. My last one was F. It started out as -1, -2. A fourth of that's going to be negative a fourth, negative half. So negative a fourth, negative half, it'll be about right there. So that's the F. Reconnect. It's kind of just stuck right in there in the middle. Now notice, if I had a point at 0, 0, 0, 0 wouldn't move. 0, 0 is going to stay 0, 0. So things that are far away from the origin get closer to the origin if I'm reducing. Or vice versa, if I'm enlarging, the further away it is from the origin, the further away it gets. If it's on the origin, it's not moving. So that was number 3. Like I said, it was kind of tricky to graph just because it was so close in there. Now 4 is a bit easier. Are we okay on number 3? So let's look at number 4. Now 4 is a half, which does make it a bit easier. Again, it's a reduction. So G started out at negative 2, 2. Well, half of that's just negative 1, 1. So negative 1, 1. That's pretty easy. That's the new G. H starts out as 2, 2. Half of that is 1, 1. That's the new H. So those two are easy to get in there. Now the other two are a little bit tricky, but not nearly as tricky as that last one. I, 1, 2, 3, down 2. So 3, negative 2. I need a half of it. So a half of 3 is 1.5. So I need 1.5. A half of negative 2 is negative 1. So again, I'm going to have to kind of eyeball this a little bit. 1.5 down 1. So it's here. But at least it's just a half. Half's not too hard to eyeball. And then one last point to go, negative 2, negative 1. So negative 2, negative 1, half of that will be negative 1, negative half. So negative 1, negative half. Reconnect. And like I said, my shape isn't changing. It's still going to have the same shape, but it will change size. It will change size. So that's what makes them similar figures. They're not going to be congruent. All the other ones we did were congruent. This one is a similar figure. And we've done similar figures before. Are we okay on number 4? Number 5 is virtually the same thing. The big difference is, instead of graphing the original one, they've got the points. So let's look at number 5. So I'm going to do the original in blue. So the original, I'm just going to graph all the original. So S was 1, negative 2, 1, negative 2. There's my S. T was negative 1, 3, negative 1 up to 3. There's my T. U was 1, 2. There's my U. V was 2, 3. There's my V. So all I do is I graph the 4th inch. Now let me go back through and connect everything. Kind of makes almost a pointy heart or an arrow or something like that. Now this side has a dilation factor of 1.5, which is 1.5. So all of these are going to get multiplied by a half. So my new S, 1 times 1.5 is 1.5. Negative 2 times 1.5 is negative 3. So there's my new S. T, negative 1 times 1.5 is 1.5, and it would be negative. 3 times 1.5 is 4.5. U, 1 times 1.5 is 1.5. 2 times 1.5 is 3. And then finally V, 2 times 1.5 is 3. 3 times 1.5 is 4.5. So all I do is I went through all those numbers and multiplied by 1.5. If you need a calculator for that, that's okay. Grab a calculator, multiply by your dilation factor.
So you just multiply 1.5 by all of them?
Yes.
And then you graph it?
Yeah. So now I'm going to go ahead and graph. So my new S is 1.5, 3. So there's my new S. My new T is negative 1.5, 4.5. So it's going to be here. So there's the T. U, 1.5, 3. So it's going to be about here. So there's the U. And then V, 1, 2, 3, 4.5. It's up here. Reconnect. There's what I have. So notice, like I said, the further away it is from the origin, the further away it gets. This here is nearly crossing the origin, and it's going to basically stay crossing the origin. The S wasn't too far away, so it just moved a little bit. V was pretty far away, so it moved even further away. Now, when I was making this the week before spring break, I think I got a little bit carried away making problems. So we're going to actually skip the next 3. They're the same thing as what we've been doing, but I want to make sure you have plenty of time to kind of start working. So go ahead and cross off number 6, number 7, number 8. Just cross those off. Now we're going to move to number 9. Now, the state test like you doing this, where they give you the graph and it says, what did it do? So on this one, I've got to figure out what's the dilation factor. Now, when you're figuring out the dilation factor, put new coordinate over old coordinate. New coordinate on top, old coordinate on bottom. If you do that, it's just going to give you the fraction, which is the answer. But you've got to remember to put the new one on top. So the blue is the new. And I know it's the new because of these little marks. Now, you don't have to do all of them. You just have to pick one of them. I wouldn't pick T because T is kind of halfway in between. That might be a little hard to figure out. So we can do U. So U, the new one is at 1, negative 1. The old one is at 2, negative 2. New over old. We'll just make it into a fraction. If I put little lines there, I get a half. 1/2, negative 1/2, negative over negative is still positive. So it's 1/2 dilation. Which makes sense because here is my original. It shrunk to the blue one. If it shrunk, I'm going to need something smaller than 1. So just double check to make sure when you're done that makes sense. Because so often I have students do it the wrong direction, and they end up with maybe a dilation factor of 2. I'm like, but did it enlarge? No, it shrunk. So you don't need 2, you need 1/2. So that was number 9. These next few go really quick. So let's look at number 10. So like I said, you don't need all these coordinates. Just pick one. So which one do you want me to use? E, F, G, or D?
E.
E. So if I pick E, new 1 goes on top. So my new E was at -2, 4. So -2, 4. My old E is at -1, 2. New coordinate over old coordinate. Make it a fraction. So I end up either getting -2 over -1 or 4 over 2. Either way, it's just going to reduce down to 2. So I have a 2 dilation. And they're all going to have the same dilation factor. So you don't need to do all of them. You just pick one. And like I said, I would pick ones that aren't like partway in between. That way you don't end up with like strange fractions and stuff. Also making sure you don't pick something at 0, 0, since 0, 0 wouldn't move in the first place. Are we okay on number 10? And 12. Now 11 and 12 are pretty much the same thing as what we've been doing. It's just not graphed. So you just need to pick one of these. Make sure you put the new on top. Right now it goes old, new, but you want to switch them. I'm going to pick W just because there's no negatives. So I'm going to do the W. Put the new W on top. Put the old W on bottom. Make it a fraction. Well, they both reduce to 2, so it's a 2 dilation. Which makes sense, because whatever these are pretty close to the origin. Then they got further away. So because they're getting further away, it must be a enlargement, so I needed something bigger than 1. Number 12, I'm picking U just because the others kind of have some fractions in there or some decimals. So the new U on top, the old U on bottom. Well, they're the exact same number. Make it a fraction. -3 over -2, well, the negatives can just cancel out. So I get a 3 over 2 dilation. So it's a 3 over 2 dilation. Yes?
Could you put 1.5?
1.5 would be fine. 1.5 would be fine. As long as it's equivalent to 3 over 2. Last two that I'm doing with you. 13 and 14. Too far. 13, 14. We kind of already did something like this, but we graphed it. We've got the coordinates. We've got the dilation factor. I'm just multiplying. So all of these are going to get multiplied by 1/2. So the new W is at -1/2. Remember, 0 doesn't move. 0. The new X, 0 didn't move. 1/2 of 2 is 1. The new Y, 1/2 of 2 is 1. Half of negative half is negative half. So all you have to do is just multiply everything by half. 14 is multiplying everything by 0.25 or 1/4. I think it's a little bit easier as a fourth. So multiply everything by a fourth. So negative 1 times a fourth is negative fourth. Negative 1 times a fourth is a negative a fourth. 1 times a fourth is a fourth. 1 times 1 is a fourth. And then the new h. 2 times a fourth is a half. Negative 1 times a fourth is negative fourth. And like I said, sometimes on this state test, they'll give you information, and then they'll want you to kind of type out the coordinates as opposed to graphing the coordinates. So I just want to make sure you realize how to do it without the graph. Now, you're going to go through the rest of it. There's 3 problems I'm getting rid of. Like I said, I'm making this a little bit shorter. Cross off 18, 19, and 22. Because like I said, I got a little bit carried away when I was making this worksheet. So cross off 18, 19, and 22. So total, there's 6 problems we didn't do. 3 of them from the first part that I did the notes for, and then 3 of them from the second part, which was the homework. So go ahead and work on it. Tomorrow, we'll kind of talk about it, go over it. Then tomorrow, we're starting probability. Probability, there's a little section on probability on the algebra and the geometry test. They just put it on there. It really has nothing to do with geometry other than it's on the geometry test. So we're going to spend probably about a week, week and a half on probability. And we're not going to have much time after that to kind of do anything else because our test is rapidly approaching, especially since it moved up a week. So that's where we are.